So, this webinar is about custom macros. And basically, when we started planning this webinar, we realized that there's a lot to talk about. So it will be in the form of several webinars, actually. Today will be the first, which will basically give you an introduction about the basic concepts which are used. So I'll start with giving you the basic information in this webinar. Now, what is a custom macro? So first of all, what is a normal macro? Normal macro are the macros you are already provided in off the shelf within COMOSYS, right? And these are quite sufficient. But as you know, in every project, there are different requirements. And sometimes you come up with certain special connections which you don't have inside COMOSYS, and you want to develop them yourself. Now, you have two ways to do that. You can use our API to do that if you have programming expertise. But if you don't have programming expertise, then you can use like the second easier option, which allows you to create quite intelligent connections, as I'll try to show in this webinar. Now, so what does a normal macro do? So this is a normal macro. This is not a custom macro. It will respond to changes. For example, if I double click on the column, and if I say this is not, instead of an HEA 400, if I make it an HEA 500, the whole connection adjusts accordingly. Similarly, if I were to, for example, go inside and for instance, change the thickness of the end plate to some other number, the whole connection adjusts itself. I can go and change the bolt diameter, for example, and the connection will change accordingly. Similarly, I can go in and change the bolt distances. So I can, instead of saying 2 into 80, I can just remove the last bolt over here, for example. So basically what I'm seeing is that the connection is responding to my input. And this is what a normal macro does. Now, a custom macro is supposed to do something very similar to this. And I will begin by showing you how we can. So what I've done is I've created a simpler version of this macro. The concepts are the same, so you don't need to repeat over here. I've omitted the stiffener plates and I've omitted the wells. Just created a cut over there. And the triangular plate, the flange plate, etc. And I will try to create this, convert this into what we call a custom macro. If you scroll down over here, we have the custom macro tools on the right-hand side. Now, let's say we want to make this connection as an intelligent connection, not as a dead connection, not something which will not respond to changes. We want to give the input. We want to change the bolt diameter. We want to change the plate thicknesses. We want to make the column bigger. We want to make the beam bigger or smaller, things like that. Let's say we want to make this kind of a connection. So the first step in doing this, in creating, is to actually model what we want. And I've done that already to save time. You model your connection. You create your cuts. You create your bolts, your plates, your welds, your stiffeners, whatever the connection is. Manually, because obviously if you had the macro, then you would use the macro. It's a situation in which you don't have a macro and you're trying to create a custom macro. So you will just model it first. That'll be step one. And the next thing you will do is give the plates and welds and bolts some names. And this will be useful. So for example, what I've done is if I double click on this plate over here, I have given it, if I go to the definitions, I've given it a name called the haunch end plate. So you go to the name section, you give it a name. That's all it is. If I double click on this one, and I've given it the name of triangular plate. If I double click on this one, I've given it the name of inclined plate. If I double click on the bolts, for example, I've given them a name of main bolts. So basically what I'm saying is that once you're done modeling, you make sure you give everything a name, and this will help us. And I'll show you how this will help us in a second. Now, once you've given the names, like I said, you can also give names to wells. I don't have any wells to show you over here, but you can give names to wells as well. So once you're done with that, you basically come down to the custom macro tools, and under it, you have the custom macro wizard. This is the first thing you will use. So when you click on this, it opens up this dialog box. And there are several different types of connections you can make. You can make a connection like the one I'm going to make over here, looking like a haunch. You can make a detail. You can make an end detail when the detail is actually located on the end point of a member. You can create a seam between two parts. You can create a custom part, which is a standalone part, basically not related to anything, just in space or by defining a point. And you can also create rebar related connections or macros. Now, we're going to talk about steel today. So I'm going to go with the connection, and I'm going to give it a name. I'm going to say haunch 1, let's say. You can choose a category. So it could be a steel connection, it could be a formwork connection, a rebar, electrical. I'm calling it steel. And you can, the subcategory basically allows you to choose where the icon will be placed in the component manager, macro component manager. So I'm just leaving it in under custom macros, which is empty initially, and you can fill it up with your own macros. And I say next. When I do that, it's now asking me to select the objects that will be created by the custom macro. So I just go in the background and I do this window selection like this. And the objects which are created by the macro have now been selected. Now I just say add objects. And those objects, it will list them as well. So you can see if you've chosen anything. You can remove objects as well. Then if I press next, it's going to ask me to select the main and dependent parts. So for this, I'll choose the column, then I'll choose the beam, and then I will right click. And when I right click, it shows me what I've chosen. It shows me that I've chosen a column and a beam, and I'm okay with that. And then I press next. Now, this is the final stage, basically, where it asks me, because I need to create an icon for this command. So if I press if I tick this box over here, this little one, which says draw screenshot boundary. If I do that, you will see that it will create a little box on the screen. And I can now pan my model into it. I can rotate it as well. I can zoom in as well. I can go to any viewing angle I want. If I don't want to see the cut in the icon, I can remove the visibility of the cuts. And this is what I want to see. Right now, it's showing me a standard icon, but if I say take a snapshot, it's going to basically use that little thing which I've used to create that icon for me. And if I say finish, now it says the custom macro has been defined. Please define the binding planes. And we'll talk about the binding planes in a second. But before we do that, there's something else I want to show you. I press OK. And basically this one opens. This is called what we call the custom macro browser. What it shows me, let me see. What it shows me is that I have a main and I have a secondary. If I open this up over here, it shows me that the main is a column with an ID of, this is the ID. It shows me a column. It shows me the beam. This is the ID over there. Similarly, it will, if I come down to the created objects, these are the created objects. So if I select this one, you can see that, first of all, if within the main ones, I can further open up these windows and I can see their properties, the general properties. So their material, the drawing groups, the formwork groups, the class, the color, the part prefixes, all the basic properties which are related to that member are accessible from here. Similarly, for the created ones, the plates, we've got 2 plates, 3 plates, 1 cut, and 1 bolt. And these are all listed in this custom macro browser. And once again, if I open them up, there are general properties, which you can see, formwork groups, colors, part prefixes, assembly prefixes, etc. And then there are part-related properties, which things like names and thicknesses and position and depth, depth offset. And then there are the chamfer related. So it's got 4 corners, this one, for example. I can give the chamfer parameters for each one over here. So basically all the detailed information which you want to access is provided on this browser. Now, let me continue. Now, what do we have at the moment? What have we done? I'm just going to press save and close at the moment. It has defined a macro. At the moment, if you see this macro symbol has appeared over here. I can just select this one and press M, and it will select the macro symbol as is customary in COMOSYS. And if I press enter, you can see that it has a dialog box. And in this dialog box, we have a plate stab and we have a bolt stab, which has come automatically. I didn't do any programming or any effort to basically create this dialog box. Now, if I go to the plate one, you will see that it has 3 lines. One is called the haunch end plate, one is called the triangular plate, and one is called the inclined plate. And these were the names I had given these. So remember, I had given this one the name of haunch end plate and the triangular plate and the inclined plate. And those names appear over here. And if I want, I can change these thicknesses directly from here. So for example, if I were to change this to 22 millimeters, it changes the thickness of that plate. I can bring it back to 12. What I can go to the bolt stab. If I wanted to change the bolt diameter to 20 millimeters, I can do that. If I wanted to change it back to 27, I can. So I have access to these variables. But these are not, this is directly giving me access to change and modify my connection. But for example, it's not perfect at the moment. And the reason why it's not perfect is that it only gives me access at this stage to modify the parameters of the 3 or 4 things which it has on the screen. But where those things are created is still not intelligent. So for example, if I were to change the size of this beam, so let me see. If I change the size of this beam from IPE 300 to IPE 400, for example, you will see things go wrong at this point, right? The cut is defined over there, but this one is gone inside the beam, for example. If I make it even bigger, if I make it for 500, for example, you can see that the cut is also now moving down because it was basically placed at the center line, and now now the cut has gone down and the top part of the beam is not being cut. So my connection is not behaving intelligently. I've got problems, and these are the problems which we will now try to solve by let me undo this by something what we call binding. Creating bindings. It's still not intelligent. We have access to the bolt diameter, we have access to the plate thicknesses, but the locations and everything is incorrect. And so let's see what we need. What we do is we select the macro. What was the problem? The problem was let me solve the problems. Let me create the problems again so that we see them. Let's make it 500. So one of the problem was that the end plate came down. It was supposed to be at the top of the beam, but the end plate came down and the cut also came down. So this is a problem. Now, I'm going to start solving this problem by talking about bindings. What do I do for that? I select any part, press M, and once the macro symbol is selected, I press this custom macro browser. It just opens basically what we already know. This one, what we already saw, the custom macro browser. But once this is open, I can now select the end plate, for example. And if you remember, the end plate, the top of the end plate was going down when the beam was getting bigger. I'm going to try and modify that. And this is done by this concept of bindings. And what bindings does is it allows me to attach the handles of the selected object to certain planes. So for example, let me select these two top points of the end plate. And when I do select the top points of the end plate, this little option opens. And at the end of it, there's this pink option, which is used for binding. And when I click on that, it allows me to select certain planes. Now, there are many options. There's a boundary planes, center planes, macro planes, outline planes. This is a separate topic which we'll explain in a separate webinar. I'm going to be using the outline planes, which means all the outline, the boundary plane, not the bounding box, but all the planes of the beam. So I'm going to say outline plane, and I'm going to say, so I've selected these 2 points. Don't forget that. I've selected these two, and I'm going to press this plus button, which means give a binding to these 2 points. Press the plus button. It says, okay, you want to bind them to which object? I select the beam. And then it asks me which plane of the beam, the side, this one. No, I want to bind them to the top of the beam. So I just do that. And when I do that, it creates these 2 bindings, which means that these 2 points are now attached to the top of the beam. So wherever the top of the beam is, these 2 points will stay there. I had another problem, if you remember. My cut was also beginning to move up and down. Okay. So what I'm going to do is I'm going to select the cut now. And the cut has its own 4 definition points. And I'm going to select the top 2. And I'm going to give it an outline plane binding, just like I did with the other one. I'm going to select this one and this one. And I'm add it to the top. And this time it says it automatically finds the distance 50. It's bound to the top plane of the beam by a distance of 50, which means wherever the top of the beam will be, the cut will be 50 above that. So it's never going to go down. Similarly, what I can do is I can go like that, and I can select the bottom 2 points of the cut, this polygon cut, and I can give another binding, select the beam, and give the bottom plane of the beam now. And when I do that, it creates another 50 for the bottom 2 points. Now, I can say press this update button now. And once the update is done, I can now save and close. What have I done? I've given a binding to the top 2 points of the end plate, and the top 2 of the cut, and the bottom 2 of the cut. Now, if I change my IPE 300 to IPE 500, for example, you see that the cut has immediately become bigger. First of all, the top is still hasn't moved down because the binding is to the top. The end plate also hasn't moved down. We have some problems with the bolts. We'll get to those. We have some problem with this one. We'll get to those. We have a problem with this one. We'll get to that as well. But the 2 things which I have just shown you, the top of the end plate is now bound to the top of the beam. And the top of the cut is bound to the top of the beam with a binding of 50, distance of 50. Similarly, the bottom of the cut, these 2 are bound to the bottom of the beam with a binding of 50. I can go back in and see them as well. What other problems do I have? Let's see. Let me just open my notes. Okay. Now the triangular plate. We have a triangular plate over here. Okay. Now let me just undo this so the beam goes back. Now this triangular plate, which we have over here, should move with the beam and the end plate, right? So these 2 points of the triangular plate should be stuck to the bottom of the beam. I know that should always be like that. So what do? I can go back to my custom macro browser and select my triangular plate. Select these 2 points, the definition points, these 2 top definition points of the triangular plate. Give it an outline binding. Press the plus sign. Once again, select the beam and show the bottom of the beam. And now I've created a binding to the bottom of the beam. I need something else as well. You can perhaps immediately tell. If I select the left 2 points, like this point and this point, what I can do is I can now attach those 2 points to the face of the end plate. So let me do that. Let me press the plus again, select the end plate, and show the front face of the end plate. Now I've got another binding over there. So I've got this one connected to this one and those two connected over there. And now basically my triangular plate is kind of stuck to these limits. Let's see the results. Let's update this. Let's save and close. And now let's, previously, if you remember when I made this beam bigger from IP 300 to IP 500, the triangular plate was going inside. Now I'm going to do that. And if you notice, now the triangular plate is perfectly located under the beam. I still have a problem with the inclined plane, with the inclined plate, but I'm going to sort that out. But the triangular plate is perfectly placed. Let me make it IPE 400, for example. Let's do that. And it's moving with it. Let me bring it back to IPE 300, which was the original definition. And we've got the original definition back. Now, let's try to fix the problem with the triangular plate. Let's see. Before I do that, let me show you another issue. For example, if I were to change the thickness of the end plate, if I were to go inside and really change the thickness of the end plate, instead of 12 millimeters, I'm going to make it 45 millimeters just to show you a problem. Now, it's become thicker, but if you notice from the side, the cut is now at a wrong place, and the beam is not being cut. This beam is not being cut because it was cut at the original location when the thickness was less. How do I solve that? Well, it's very easy. What you do is you go back into your custom macro browser and you select the cut. And what you do is you select all 4 points of the cut, all 4 definition points of the cut, and you say you want to bind them to the outer face of this end plate. And that's all you need to do. Once you do that, you'll have 4 new bindings, and now the cut is fixed to that plate. Now you just say update. You can close this. You can say save and close. And now from the right-hand side, if you notice, the cut has moved to the outer point of the thickness of the end plate. And now it is cutting the thing properly. If I were to go back inside and change my thickness back to 12, you will notice that the cut now also is moving because of this binding which we just gave it. Now, let's see. So we changed the thickness. We saw that the cut was incorrect. We modified that. Now the flange plate. This plate also has its own issues. What do we need for this? For the first thing we want to do is that this flange plate, it should be stuck to the bottom to this plane of the triangular plate. The flange plate should be stuck to the and I can't see it, so I'll just basically what I mean to say is this plane, right? So let me just select the macro, go like that, select this one, and if I say I'm going to give binding to this one and this one and this one and this one, and if I say I want to give it an outline binding, and to choose the object, I select the triangular plate. And once I select the triangular plate, I can select the bottom plane of the triangular plate as well. And when I do that, immediately my triangular plate is now attached to that bottom plane. It's still not enough though. I also want these 2 points to be stuck to the bottom of the beam. So what do? Once again, I go to my binding, press plus, select the beam, select the bottom plane, and these 2 points are now stuck to the bottom of the beam. Similarly, without closing it now, because you're getting used to it, these 2 points need to be stuck to the end of the end plate. So I'll just press my plus button, select my end plate, select my surface, and that's it. I'm basically being able to, if I save and close, you will see now if I go back in, and now if I change this from 300 to 400, you can see that now the triangular plate is also moving. I'm sorry, the flange plate is also moving. I can make it even bigger. We still have a problem with the bolts, if you see, but we'll get to those. Getting back to making it 500. But once again, everything is moving along with that. Let me bring it back to 300. So we have a normal looking connection. Now, as you can see very quickly, in a few minutes, I've created these bindings. And now I have, instead of a dead connection, I have a very intelligent connection. It is responding to my needs. I can make the column bigger. I can make the beam bigger. It's basically starting to behave like a normal macro. Of course, there's a lot more to be done. But the whole idea is that within a few minutes, you've already got some intelligence in there. And now it's behaving like a normal macro almost. Now let's talk a bit more about what we call. So we still, for example, if you were to say I wanted to change these bolt distances, something like that. So we can talk about those. If you wanted to talk about if I wanted to change the length of this haunch, for example, how do I do that? Things like that. So let me talk about a little about those things as well. Let's open the variable editor. So let me click on M, open the custom browser. We've already talked about this one. We've talked about how you can select objects and give them their bindings, etc., by selecting the different definition points and then attaching them. But I'm going to talk about something else now. I'm going to talk about the variable editor at the bottom left. This is a very this is the place where you actually put even more intelligence into your macro. So if I press on the variable editor, you see that it opens up and it already has actually lots of variables inside it. So B01, 02, 03. The word B, by the way, means binding. So if you remember, we've created almost like 22 bindings up till now. Some of them are stuck to planes at a distance of 0. Some of them are stuck to planes at a distance of 50, whatever the numbers we want. These are basically the existing variables which I've already created by using bindings. So every time I use a binding, I create a variable in the background, which I can then go and actually modify these values as well. And I'll show you how to do that. But what I want to do before I do that is talk about if I say add over here, remember these are all binding variables, and binding variables are automatically created. If you see on the top, it says custom variables, binding variables, and object variables. So there are 3 types of variables. The binding variables are created automatically. The object variables you can create from objects, but the most important ones are the custom variables. Now, to do that, you press the add button. Okay. So I'm going to press the add button. It asks for a name. So let's say I want to modify the interbolt distances. So I'm going to give it a name of bolt dist X, basically the vertical direction in this case. So I'm going to give it a name of bolt dist X, and I'm going to say, okay. If you notice, it adds this bolt dist X as a new variable. If I wanted to filter out, if I don't want to see all the binding variables at this point, I can just filter them out. I'll see only the custom and object variables. There's no object variable at the moment. So I've created this bolt dist X. Now this bolt dist X is basically the distances between the bolts. So 80, 80, 120, 80, 80. It's basically a space. So it's got multiple inputs. I want to say something like 80 from the top, and then 2 into 60, and then 120, and then 2 into something like that. And for this, we change what we call, if you notice, the variable has a formula, which I will write in a moment. It has the value which comes from the formula. So whatever the formula will give, the value will take that value. It has a type. Initially, it will give it no type. So for this one, for the bolt dist X, the type should be, and we'll discuss this at length in a different webinar. It will be a length list type. A length list basically means that it is multiple numbers. I want to show this in the form. If you remember, the form was automatically created. I want to label it as bolt dist X. I can change this label if I want. But what should the number be? I'm going to go in there and I'm going to write that it needs to be in quotation marks over here. I'm going to say 80 space 3 into 60 space 120. And then I'm going to close the quotation marks. 80, 3 into 60, and 120. This is just a default value I'm giving, right? So I've created a variable called bolt dist x. And then I've given it a default value. But it's just a variable. It's not connected to anything. It's called bolt dist x. I've given it given it a value. Now let's see what we can do. If we close this, and we go back to the custom browser, and I go to my bolt properties over here. If I open them up and go to the part properties, you see there's the grid x, the x distances, right? These are the x distances which it currently has. But I don't want it like this. I want to be able to modify them. So if I select on this, and if I right click, and I say set function, and instead of whatever it's giving me, if I say bolt this was it x, I can even, yeah, it was bolt dist x. Okay, so I can copy it from there as well. Yeah. And if I say okay, immediately it brings in those default numbers which I had inputted over there. Now, what happens now? If I save and close this, and if I go back and open my macro dialog box again and go to the general tab this time, I see that I have this new variable over here, and I have access to that thing which I just entered. So I can now go in and say, maybe I can say 2 into 70 and 120. And then I can, instead of that, I can do another 2 into 75. So now I have access to the bolts as well by introducing a custom variable. This is very, very useful. Now, what else can we do with this? We can bind the bottom of the triangular plate to the last bolt. So or we can bind the bottom of the end plate to the last bolt. So what I want is that for example, if I were to do something like this, I want to make it like 5 into 75, the bolts are going outside and they're going beyond my connection. So what I want is to actually bind the bottom of the base plate to the bottom of the bolts. That will be really cool. So let me just bring this back. Okay. And go back to my definition. To my, if you remember, I was using the custom macro browser. So what do? I bind the bottom of the end plate to the last bolt. So I select the end plate. I select these bottom points, these two, and I say I want to give it a binding. But I select a bolt this time. And when I select a bolt, it gives me certain, the bounding box of the bolt. So I want to take the bottom bounding box. If I do that, it binds that and it gives me a number of, the current number of 255. It's a bit too much. I want to like keep it always like 100 more than that. So not 255, I can modify those to 100. And I can say update. So my bottom of my end plate is now updated to that. What I can also do is bind the bottom of the triangular plate, which is this one. So I can bind this one to the last bolt as well. So if I go in and I press the outline and I press the bolt again and I press the same one, and it gives me another binding of 220 with the bolt, but I don't want 220. I want it to be something like maybe 80. These can also be variables, as you've already guessed, perhaps. So it's gone now. Update over there. And if I save and close, everything gets exhausted. Now, if I go back into my macro and I go and add a few bolts, let's say 3 into 75, I see that my haunch is now responding according to those bindings, right? So that's very, very useful. What if I wanted to control this horizontal distance of the haunch? What would I do that? Well, it won't be very, very difficult. What do I do? It's exactly like what we did. I'm just going to finish in a couple of more minutes. So I realize it's a bit over time now, so I don't want to take too much. This is basically an introduction, and we'll keep talking about this. So I go back into my thing, and I open up my browser, and I go to the variable editor, and I create another variable called the haunch horizontal distance. Let's call it haunch horizontal distance. There it is. And it's going to be, I'm going to give it a type of, not lengthless, but give it a type of length. Its type is length. And I'm going to give it a default value of, say, 500. And I'm going to say, okay. So this is what I want. It's the length type. It's called haunch, HOR. That's the name of the variable. Close it. It's still not attached to anything. What do I do with it now? What I do with it is if I select this one, and if I select the triangular plate, and I select this point, and I give it another binding, but when I say I give it another binding with the end plate and the face of the end plate, and it gives me a default, the distance it finds out that it's 600 at the moment, but I want to modify that, and instead of 600, I want to copy a variable which is called the haunch horizontal variable, and I just say paste then. Okay, and it brings in that variable, and I say update, and that's it, and save and close, and I've got my modification done. Now, if I go in there, go into the box again, I now have control over the haunch length. I can make this 1000 if I want. I have control over my bolt distances. If I change it to 2 to 75. So in front of would have been done in like 5-10 minutes. I've basically created a pretty reasonable haunch connection. Now, of course, you can add other bindings. You can add the bolt distances in the Y direction. You can talk about. You can make the end plate edge distances bound to the bolt line as well. There's a lot we can do. You can add other stuff as well. But what I wanted to show you in this first webinar is how easily you can, without being a programmer, how easily you can, just by using bindings and custom variables, create a reasonably powerful connection, which if it's not available off the shelf, you can use it in your company. Now we'll have many other webinars, at least 4 or 5 other webinars on this topic, and we'll include topics like how to create custom forms. So, for example, right now, the form is basically a standard form. It's got these tabs, but I'll show you ways where you can put in pictures and create your own custom forms. That'll be a webinar on itself. Then we'll talk about the types of binding planes, which we haven't talked about yet. We just only talked about the outline type. We'll talk about how to use there's an extensive function library which you can use, all trigonometric functions, other types of functions. Then we'll talk about in another webinar about how to use text files and how to set up the environment, how you can use these connections all across your company. We'll talk about rebar macros. We'll talk about calling other macros from within this custom macro, etc. So there's a lot more to talk about. Of course, it can't be fitted in half an hour, but this was basically an introduction. We hope you liked it. I'm going to go back to the